Kia ora, hello everyone. Welcome to our Snack and Learn webinar today. Good morning to those of you in New Zealand, good day to those of you elsewhere in the world. Today we're going to be introducing the multimodal network that we're busy and currently underway with developing for New Zealand's transport sector and bringing you some use cases of navigating the future with it. Just some housekeeping questions. So there will be time for questions at the end. I do encourage you to write these in the questions box in the GoToWebinar control panel during the presentation. And then also a reminder that the slides are available for you guys in the platform for downloading if you would like those. Just a little bit about your presenters today. So just a little bit about myself. I am a principal asset manager in the Christchurch office in New Zealand for WSP. On this project, there are a number of us, but with me today, I've got Leah Watts with NZTA Waka, Kotahi, and she is the product owner of our network model. One of the fun facts that I have about this project at the moment, as you can see on screen, there is a number of people who are working on this, and we are across 8 different offices and locations in New Zealand.
Morena, thanks Claire Louise. As Claire Louise said, my name is Leah Watts. I am the lead advisor for the development of the asset management data standard within NZTA, the New Zealand Transport Agency Waka, Kotahi. And I'm also the product owner of the multimodal network and working very closely with WSP. I suppose an interesting fact from my perspective is that within New Zealand, the New Zealand Transport Agency manages state highways. But local roads are managed by 68 independent road controlling authorities. So that does mean a lot of engagement as part of the approach that we're using moving forward. So the agenda today that we're going to run through is we're going to give a high-level overview of what the asset management data standard is, look at what the network model is, and some case studies so that we can maximise the opportunities that we have for developing this. The Asset Management Data Standard, or AMDS as we tend to call it, is a data standard that informs activity management decisions for transport. It's so we can plan and implement activities which deliver service as expected for the cost expected. It's a common language that describes the service, impact, and asset life cycle across the transport system. The standard creates a structure that will ensure consistency of data collection, enabling road controlling authorities, New Zealand Transport, Waka, Kotahi, and the transport sector to collect better quality data, helping them meet their asset management goals. Development of the standard and the implementation approach is a joint collaboration between NZTA Waka, Kotahi, the road controlling authorities, RCAs, maintenance contractors, and service consultants. The AMDS we see as one of the building blocks to enable digital engineering approach by providing an agreed set of definitions, labels, categories, and data requirements for land transport assets across New Zealand. With the increased government emphasis on infrastructure, the AMDS will build on the maintenance work to date, including adding additional zones and supporting multimodal assets as part of capital projects, providing the asset information requirements moving forward. New Zealand's thanks Claire Louise. New Zealand transport sector is a vital component of the country's infrastructure, encompassing road, rail, air, and maritime. It plays a crucial role in connecting communities, supporting economic growth, and ensuring the efficient movement of people and goods. New Zealand has over 180,000 kilometres of road, 4,500 kilometres of rail, and over 20,000 bridges, owned and managed by 68 different RCAs, which are road controlling authorities. The Asset Management Data Standard Initiative is a significant effort led by New Zealand Transport to standardise asset management data across the transport sector. The AMDS aims to create a consistent framework for collecting, managing and sharing asset data, ensuring that all stakeholders have access to accurate and reliable information. Implementation of the AMDS will enable multiple benefits across the sectors. These include cost savings and efficiencies. A single standard will create clear requirements for data collection, monitoring, and processing. This will lead to improving alignment of rules and processes across the RCAs and suppliers. Processes will be more accessible, efficient, and predictable as a result, and savings are currently estimated at 180 million over the next 10 years. Better value for money through prioritisation. Better quality data will enable suppliers and asset managers to distinguish high value and low value maintenance work. Linking maintenance expenditure with performance information allows for identification for over or under investment across our RCA portfolios. Expenditure can therefore be targeted to where it has the greatest effect, improving outcomes without increasing costs. Currently, such investigation is not possible without dedicated data analysis, often requiring external expertise. We should have improved information sharing and collaboration. A consistent data standard will increase the efficiency and accuracy of information sharing between organisations who are using different software. The risk of clashes, use of incorrect materials, and other coordination errors will also be reduced. Current state, one data expert noted that asset condition data can take up to 9 months to appear in local systems due to the translation requirements and local IT restrictions. From a scenario planning and decision-making viewpoint, accessibility or accessible and reliable information can improve strategic planning and portfolio management at the national level, increasing the ability for senior leaders to understand and respond to emerging trends. Stakeholders agreed that AMDS would improve the client's ability to understand cost drivers. Two asset managers, for example, noted that local geography and direct weather after maintenance and direct weather directly affect maintenance costs, but current systems and funding arrangements do not consider this information. So more consistent data and analysis would support that evidence-based decision making. Ultimately, the AMDS contributes to a more resilient and sustainable transport infrastructure within New Zealand. So what is it? Well, in partnership with the sector, we're creating a living centreline model, a single source of truth. In essence, the network model is really a simple digital representation of where users can travel by any mode across the transport network now and into the future. The network model is the backbone to the asset management data standard. It underpins the AMDS and is really foundational to pulling all of those pieces of our data ecosystem together. The diagram on the right-hand side illustrates some of the layers and the depth of our infrastructure and planning and sits at the base of this network model. The rest of the AMDS, the location of the assets, lifecycle planning, operational management, reporting, all sits above it. It's informed by the network model, but it's not embedded within it. A key message here is the network model and the information that we bring into the model itself is very basic, very simple. But what it will inform in terms of downstream processes and reporting is comprehensive and will bring together the full spectrum from planning, design, right through to maintenance, operations, and reporting. So what will the model look like, or what will it provide? Well, at its simplest, it's a direct refinement of our current road centre lines, updated with a basic understanding of not where vehicles, but also pedestrians, cyclists, and other micromobility and public transport users can travel. Rail, ferry, pathways, and tracks will all be included with their own centre lines. Some of the direct benefits that we have as part of this is that the network model will be open access data and fully connected, allowing us to run analytics and route planning across our network and improve the visibility of modal transport. So what value will this bring? Well, unlike other map platforms that we interact with as members of the general public, the network model is designed in partnership with the asset owner and to connect infrastructure to customer journeys. It will help us to improve investment decisions, drive efficiencies, and ultimately enhance the travel experience of the public. The network model helps us to think bigger and more collaboratively. As our sponsor, business sponsor David Darwin also highlights, this is about taking the difficult out of integrating foundational asset information and enabling the value add that the new capability and released resource can bring. The project will lead to cost savings and efficiency gains, both in data collection, processing, as well as better value for money through improved planning. The learnings that we've gained through the wider AMDS program and the network model and development underpins it, and they're applicable across any geography or controlling authority, and it's foundational to moving forward towards that digital twin. And on that note, I'll hand over to Claire Louise.
Awesome, thank you very much, Leah. So the only way that this is really happening with a network model is by having a centralized aligned source of data. And to achieve this, we've had to look at how data is captured and all the many different sources that form this baseline. The way we do move from A to B is changing, and this is due to the connectivity of routes through many different mode options, restrictions that may exist on the network, and the way that infrastructure is built on different parts of the network across New Zealand. So the network model aligns with the data from all the controlling authorities in New Zealand and is in that common language. Through this, the network model can now provide a solution which is ready to be the backbone for any innovation across New Zealand. This will be available to industry, which means anyone who needs to use it can. So the network model enables a comprehensive understanding of this transportation landscape and all its different interdependencies. It will enable all stakeholders to make those informed decisions and effectively manage and optimize the country's transportation systems and services within the development of a digital twin framework. This network model data set covers two base requirements for the foundation of building a digital twin, and those are the different transportation modes and elevation that's embedded within it. I'm going to just run you through a couple of case studies that we have, and then hopefully open up the innovation to the rest of you. So it's never really about the speed we travel, it's about the journey to get there, right? Especially when you're traveling around New Zealand. In New Zealand, we can use the National Speed Limit Register as a supporting operational layer. This contains all the speed limit extents for different regions and areas, and by relating this information to the network model, we're able to use this data set for so many things, not just the speed limit captured. Instant benefits are time-based analysis against other data sets captured in the network model, such as the travel modes, and through this you can build other additional operational data sets that you maintain and manage. Innovating on the network model with an operational data set involves not just improving data for an organization and its accessibility, but it also starts the journey on exploring ways to enhance user experience and address emerging challenges. Capital projects, asset management data standard compliance from start to end, integrating the network model from day of conceptual design in civil 3D BIM models, etc., allow to integrate the standard from the very beginning. Through this, inventory assets in the network model can all integrate and include the important information from the very beginning, and then take it through to making informed decisions with up-to-date data. You can understand and compute movement changes across the network. An example on screen is just a congestion analysis. Loadings of vehicles you can view as a time-scaled, as shown in the example as well. You can view and manipulate any traffic, or look at the different types of impacts that new neighborhoods could potentially have on your network, region and projects of national significance. We can see if the network, by changing it, if it can take the pressure or if it's loading pressure somewhere else. And you can also test to see if the asset can handle the changes. You can essentially review, view, and understand any cascading impact of adding or deleting any parts of the network on your or your neighbor's boundary assets. And this is a response and reflex at the desktop level. You can check in on any long-term plan ideas and get the transportation planners involved in modeling their traffic and neighborhood growth for understanding maximum and minimum options presented from the changes. You can integrate with other innovative projects and deliverables for more informed, more connective, and faster results. You can look at targeted action response plans within Asset Management Data Standard Network Model baseline for information. And here on screen, WSP have set up and actioned multiple dashboards for controlling authorities, providing a platform for those response action plans, and can have included live information from weather forecasts, rain events in specific parts of the network. And this allows for targeted approaches in the network risk and safety responses. If you'd like to know more, get in touch. We can talk about WSP Canary early warning systems for your region, and this is also now implementable all over due to the common language of the AMDS network model. Continuing our form of resilience, there are many other different innovative projects. This is another one, a case study using GeoNet's shake map and results, having a look at how earthquake, I would say resonance, but can affect the network model. In this case, we've got some bridges on the state highways. Have a look. We tested over a certain threshold, which ones would need to be closed and checked, and then also what the reroute ability of the network model then is. So the network model can be used in conjunction with climate data to assess future vulnerability of the transport network. The direct benefit here is that the decisions are data informed and can be made for future developments of climate resilient infrastructure and potential detour routes. The network model also brings the opportunity to spatially test any of the transportation's infrastructure resilience or possible mitigation strategies against impacts of any climate events. This is crucial to the network longevity and assessments across all of New Zealand, and can be used to assess future vulnerability of transport modes and transport networks in either a current or future planned versions. This allows for smart infrastructure planning across all modes and empowers organizations with that locational intelligence. And then just closing up, some of the lessons we've learned that WSP has gained along the way through the wider Asset Management Data Standard project and the network model that underpins it are applicable across any of the geographic or controlling authorities and are foundational to the journey towards digital twins. I'm going to close out our presentation here and open the floor for any questions you may have. If you are interested, please scan the QR code. There is a story map that goes into a little bit more digital detail about how the project has come to be. Thank you.
Claire Louise, I see there are a couple of questions there. Would you like me to read them and then either you or I can respond? How does that sound?
Yeah, let's go through those.
Okay, so how does the model relate and respond to the public health potentials for the multimodal network? I might hand that to you, Claire Louise.
Can do that. So there's a few ways we can look at this. The way I'm reading this question is kind of having a look at the benefits or the potential accessibility to public health locations across your network, and how people may travel to get there by having a look at a potential footpath analysis to the nearest aid clinic or hospital. Those can then be done, I think, very beneficial in our pre-tests in the network model, where we were able to understand how long it could take a person to travel across a pathways to a bus network back to a location again. Definitely understanding in terms of buffers, what is within 5 kilometers, what is within 10 kilometers, those sorts of things for all types of modes.
Cool. Question 2. Is this separate to, in addition to, or complementary to the New Zealand National Agent-based model, which ARUP was developing for MOT? I can probably respond to that. So ARUP with MOT, from my understanding, are developing a framework from a metrics and performance benchmarking perspective for traffic and flow, etc. on there. I may be wrong a little bit in my assumption here, but please correct me if I'm not. We are working with MOT as part of the process, but we're a little bit different. I mean, they could use our network model as the base layer, to then present. I think they're currently using TomTom data as their base layer, so that would be a little bit of a transition to using an open data. And yes, definitely working with them as that sort of moves forward in its development. Another question. So what are the travel demand assumptions behind the network supply model? Claire Louise?
I'll take that one. So the network model doesn't make assumptions on travel demands. You can use the network model with the travel demand information to make an operational layer. So the one thing about the network model is all the data and details that need to be are embedded within it at the most basic level for use to do any other network analysis, such as demand assumptions, things like that. So one of the examples I'd shown in case studies, we'd used traffic loading as a supplementary source, and then created a secondary layer, which then became my operational layer to manage and maintain going forward.
Cool. Next question, and I might give this to you as well, Claire Louise. How does the program impact major transport dilemmas, such as replacing the Auckland Harbour Bridge?
We're actually in talks with AT at the moment, so they're about to go through their transition. However, I'm fairly certain that they've got some analytics for the bridge already underway. This network model will probably enhance that analytics by including all the modes that can cross over it. So if it is public transport, pedestrians for pathways, and then different types of vehicles. So if it is a light vehicle or heavies, those are benefits that it will bring to that project, as well as on-flow effects. So you can test when we have to close the bridge due to winds and things like that. You can look at all the potential detour routes, or even detour routes while the bridge needs to be closed for some sort of maintenance or repairs.
Another one for you. Why not use Google or Apple Maps?
So Google and Apple Maps is available to anyone and everyone who may like to use them. However, the network model is updated and controlled by the controlling authorities, which means that their data and asset information is up to date. This is also for asset managers and planners. So by using Google or Apple Maps, you may not get the details you require, or up-to-date detours or approved detours and routes and restrictions that exist along specific parts of the network.
Got another example, or not an example, another question. Can this be used with other data sets? And I could start with responding to this a little bit. We're working really closely with a freight project within New Zealand. So they are capturing freight that moves around the current network. They do that using telemetry information, and they're using the network model as the base for that, and then overlaying that over the top, being able to see where bridges and tunnels are, and then being able to see how those heavy vehicles travel over there and the impacts and risks that it may identify as part of that process.
Yeah, I can expand slightly on that, Leah, as well. So other data sets that will be useful to have in conjunction with the network model is your resilience parts of your network. So we're looking at your geostructures, your bridges, things like that. You can have a look at, I had an example, a case study on screen where we had looked at the geohazard shake map versus bridges. You can start to build on and use many other data sets in conjunction with the network model, as the core information provider for route and network analysis for modes to travel. Is a very good example of that one as well.
Cool. Where else is this being used?
So I'll answer this, and Leah, you could probably follow up with a little bit more. So network models are used throughout the world. However, we've also gone into using an asset management data standard, so that common language behind this one, which makes this project fairly unique in itself. It's implementable because of that unique and common language throughout all of New Zealand as well, and can be transplanted elsewhere if required.
I'm just trying to think a little bit outside of the square. I mean, we've had lots of conversations with Ausroads, who are an Australian-based organisation. They have developed some structures which are similar and aligned to our asset management data standard. I suppose in Australia they struggle a little bit more than New Zealand in that they've got different territories and all of those different territories and different ways that they capture information. So they have struggled to be able to roll that out, whereas we've been quite lucky within New Zealand that we have 68 local authorities or road controlling authorities that we work very, very closely with. The engagement has been huge as part of this project. And so we've been able to transition more quickly and more effectively than other countries at this point in time. I'm not sure of anywhere else. So I think that closes that question off. At this point, there are no additional questions. So I think we're probably at the stage where we could wrap this up. So thank you all very much for attending, and hopefully you managed to get something out of the presentation.
Yep, thank you very much, everyone. Have a wonderful day.
Right, thanks.